Okay, let's take a look at slope. Slope might be described on a graph as the steepness of the curve. It might be described in general as the rate of change of the function. It's how one variable is affected by the other variable. Um, the steepness can be calculated by looking at the rise versus the run. The rise is a delta y, or a change in y. That symbol delta just means change in. So the change in y versus the change in x. The steeper the curve, the greater the slope, the more this changes with respect to that. And then how we would calculate delta y, well, really it's just the rise. And the rise is the difference between our two y values, and the run is the difference between our two x values. The variable we use for slope is almost always the letter m. And so the standard slope formula that you would see if you looked it up in a book would probably be this last one, that the slope is y2 minus y1 over x2 minus x1, where these are just points. And so let's find the slope from a variety of things. Let's say we wanted to find the slope from just 2 points. So let's say we had a point, 2 comma 4, and we had another point, 5 comma 16, and we wanted to find the slope. Okay, so these subscripts here, like what we would call this point 1, and so this is like x1 and y1, and this would be x2 and y2, oops, y2. And if we plotted them on a graph, we could do that. So it'd be like 2 and 4, and 5 and 16, and it would look something like that. And the slope is how steep this line is. And if we wanted to count, we could look at the rise and the run. And again, without even doing any math, if we were at 2, we went over to 5. That's a run of 3 over. And then 4 all the way up to 16 is up 12. And then the ratio of the rise to the run, so the slope, would be 12 over 3, and that has a slope of 4. Right, so this variable increases 4 for every 1 we go over. So over 1, up 4, over 1, up 4, which of course is the same thing as going over 3, up 12. If we wanted to use more of the systematic way of doing that, we could find the slope. We could say that m is going to be 16 minus 4 over 5 minus 2, which of course is just 12 over 3, which is where that 4 comes into play. Okay, so it doesn't really matter if you think about a graphical perspective or if you just plug into the formula. The slope is how the y variable is changing with respect to how the x variable is changing. Okay, we can look at 2 points, or we could look at equations. So maybe if I asked you, here's an equation that says 3x minus 7. Well, what is the slope? Well, it's actually right here, right? The slope here would be 3. We know that equations are written in the form y equals mx plus b. So in this way, we know that the slope is 3 and the y-intercept is 0 comma negative 7. So if we have an equation, we can have it like that. We could have an equation where you might have to do some work. So what if we had like 7x plus 3y equals to 15? Well, we might have to actually solve for y first. So let's manipulate this. Let's subtract 7x to the other side, and let's go ahead and divide by 3. And again, dividing this side by 3 is dividing both of them by 3. And now we can see that the slope is negative 7/3. So if we have an equation and it's written in the form y equals mx plus b, we know what the slope is. If we have an equation maybe like in standard form, if we solve for y, we then can find the slope. Okay, so we can find the slope given an equation. We can find the slope given 2 points. What if I were to tell you you had the x and y intercepts? So what if you had an x-intercept of 4 comma 0 and a y-intercept of 0 comma 9? Well, I mean, that's really just as easy as doing this, but it's also very visual in that, right, this is the point here, and that's the point there, right? In this case, this would be a negative slope, right, because it's going to go down. right? A negative slope indicates a negative rate of change. So as we increase x, we actually decrease y. And so this is just down 9 over 4. So it's like a negative rise, right? So then in this case, we'd have a negative 9/4 slope. And if you use the equation, it'd be the same thing. It'd be 9 minus 0, and then 0 minus 4, and you'd get negative 9/4. So we can get them from the x-intercepts, we can get them from two random points, we can get it from an equation. We should be able to find the slope from a graph. So if I just come over to this graph, and then let's just draw something. Okay, something like that. And again, I don't know if I drew it perfect, but let's just pretend that you see that grid point, and that grid point, and that grid point. You're like, oh, let's pretend that pattern is true. Again, I don't know if I actually drew it perfect enough, but it would be something like that. And you say, okay, well, what's that slope? And you're like, well, from the graph, you can just find 2 points. Let's just focus on these 2 points. And I'm going down 3 and over 1. 3 over 1, and it's downhill. So that's got a slope of negative 3. Okay, let's go over here, and there's 2 other scenarios I want to focus on. What if your equation was horizontal? Okay, all right, that's the graph, and the equation would look like y equals 5. Well, what's the slope there? We'll go to the definition. What's the rate of change of y with respect to x? Is your y value changing at all? And you're like, no. Is there any rise? You're like, no. You could even pick 2 points, right? There's a run, but there's no rise. And so that has a slope of 0. So horizontal lines have equations that look like y equals to 5, and they have slopes of 0. Now, if I looked at a vertical line, let's say this guy, do you see how every one of these x values is the same? And so the equation of the line would be like x equals 5, but the slope, you can say it in 2 ways. You can say it's undefined, or you could actually just call it an infinite slope. Okay, so we can have positive slopes, negative slopes, 0 slopes, and undefined slopes. Undefined slopes are where the line is going to be vertical. The equation of a vertical line looks like x equals 5. Slopes have 0 when they have no rise, and their equations look like y equals a number, because if you look, all the points on this line, y is 5. All the points on this line have an x value of 5. Okay, this is probably the standard way to find the slope between 2 points. If you want to find the slope given an equation, you probably should put it into y equals mx plus b, because once it's in that form, then you know the slope is just m, right? So once you get it in that form, you know the slope is 3, and you know the slope is negative 7/3. Okay, hopefully this gets you started on finding the slope, and again, in a variety of ways. Find the slope given points, find the slope given a graph, find the slope given an equation, and you should be able to go back and forth between all those things.